we will now discuss another important concept in thermodynamics, that is adiabatic expansion of a gas. What does this process mean? In an adiabatic process, heat does not flow into the system or out of the system. In other words, when we deal with the amount of heat added, there will be no amount of heat added in an adiabatic process. So that dQ will be equal to 0. This is the most important characteristic of an adiabatic process. The amount of heat added will be 0. There will be no heat added. There will be no heat removed from the system. Now tell me, therefore, if a gas expands adiabatically, that means no heat is added or removed from the system. So when a gas expands, what is likely to happen? What does expansion mean? Well, expansion means the gas is doing work. Now, if a gas has to do work, it has to have energy. If no external energy is provided, where is the energy going to come from? It is going to extract energy from within itself. In other words, it is going to use part of its internal energy to do work in expanding. As a result, an adiabatic expansion will produce cooling. Why produce cooling? Because the energy needed for doing the work of expansion is taken from the internal energy, which will then reduce the internal energy and therefore produces cooling. In the same way, an adiabatic compression will produce heating. A very important concept to know these things. Since heat does not flow into the system during an adiabatic expansion, the energy needed to do the work to expand is derived from the system itself, from the internal energy of the system. We will obtain an equation for the adiabatic process using the equation of state. What is the equation of state? Well, of course, the equation of state is PV equal to nRT. And the first law of thermodynamics. What is the first law of thermodynamics? Anybody know what the first law of thermodynamics is? Yes? dQ equal to du plus dW. And what is dQ for an adiabatic expansion? Is 0. Alright. So dQ equal to du plus dW equal to 0 for an adiabatic process. Alright, now, what is du? You remember du? du over dt is Cv. So du is Cv dt. And what is dw? dw is pdv. So this equation now becomes du becomes Cv dt plus dw is pdv equal to 0. And now we use the equation of state, which is PV equal to nRT. What can we do there? Well, we can find the value of PdV from there. Is that right? We can find P equal to nRT divided by V. So what happens if you replace this P by nRT divided by V? We have Cv dt plus P is nRT divided by V, and I wrote that V here as dV over V equal to 0. I hope you understood that. P is replaced by nRT divided by V. So you got Cv dt plus nRT times dV over V equal to 0. Now divide by Cv times T each term. What happens when you divide this Cv dt by CVT. You will get dt over t. There you are. CV dt divided by CVT is dt over t. What do you get if you divide nRT? Alright, let's take this one. nRT is divided by CVT. The t and the t will cancel. We got nR divided by CV times dV over V equal to 0. Alright, these are sheer mathematical manipulations. And of course, all physical principles are derived using mathematical principles. Alright, we can now, do you remember this nR is Cp minus Cv? You recall that one? Cp minus Cv equal to nR. And so this nR can now be replaced by Cp minus Cv. We have dt over t plus nR is Cp minus Cv divided by Cv times dV over V equal to 0. Alright, let's simplify this. Cp minus Cv all over Cv. We can now divide each term by Cv. This will be Cp divided by Cv minus Cv divided by Cv. And do you remember when we talked about the speed of sound? That was a few lessons before. When you talked about the speed of sound, I gave you an equation for the speed of sound. Does anybody recall that? Well, I must be joking. Well, speed of sound V equal to square root of gamma P divided by rho. Well, I hope it rings some bell. At that time I told you we will deal with that particular quantity gamma later on. And I gave you the value of that gamma there. I said use the value of gamma as 1.4. Alright, this is the time I'm going to introduce that concept of gamma. You know what gamma is? Gamma is the ratio of heat capacity at constant pressure divided by heat capacity at constant volume. In fact, gamma equal to Cp divided by Cv. That is the quantity gamma. And for a diatomic gas, Cp is 7 over 2 nR and Cv is 5 over 2 nR. Is that right? And Cp divided by Cv will be 7 over 5. What is 7 over 5? Is 1.4. And isn't that the value I gave you to use that time? Air. For most practical purposes, air is the diatomic gas and the value of gamma is 1.4. So, when you divide here, Cp divided by Cv, that Cp divided by Cv is that gamma. Okay, let's do that now. So, simplify this. This will be dt over t plus Cp over Cv minus Cv over Cv is 1 times dV over V equal to 0. And that is the ratio of Cp to Cv is a constant and is denoted by Cp over Cv equal to gamma. And so our equation now becomes, how does that become? It'll be, for a monoatomic gas, let's look at the value of gamma. For a monoatomic gas, Cp over Cv, Cp is 5 over 2 nR for a monoatomic gas, and Cv is 3 over 2 nR, and that will be therefore 2.5 divided by 1.5, or for a monoatomic gas, Cp divided by Cv, that is gamma, is 1.67. And for a diatomic gas, I just gave it to you, Cp is 7 over 2 Nr, that is 3.5 Nr. Cv is 5 over 2 Nr, and that will be 3.5 divided by 2.5 is 1.4. The value of gamma for a monoatomic gas is 1.67. For a diatomic gas, it is 1.4. So this Cp over Cv will now become gamma. So the equation for the adiabatic process now becomes dt over T plus gamma minus 1 times dV over V equal to 0. Well, this is a differential equation, a very elementary differential equation. We can solve this equation. Do you know how to solve this equation? dt over T plus gamma minus 1 dV over V equal to 0. The equation for the adiabatic process can be obtained by integrating each term of the equation. That's right. This can be solved by integrating each term. Let's do that. So integrating this gives, well, I'm assuming that you know these integrals. Tell me, what is integral of dt over t? We talked about that in the last class. Integral of dx over x is ln x. Integral dt over t is ln of t plus gamma minus 1 is a constant, so that will be gamma minus 1 times integral of dv over v will be ln of v is a constant. So integrate each term. That will give you ln of t plus gamma minus 1 ln v equal to a constant. Well, I can rewrite this. Can you use the properties of logarithms to write this? Gamma minus 1 ln v is the same as ln of v to the power of gamma minus 1. Is that right? Yes. So that will be ln t plus ln v to the power of gamma minus 1 is a constant. And now the left hand side is the sum of two logarithmic terms. Can you combine that into a single logarithmic terms? What is ln of t plus ln of v to the power of gamma minus 1? It will be ln of tv to the power of gamma minus 1. Log of a plus log of b is log of ab. So you have ln of tv to the power of gamma minus 1 is a constant. Now, watch this again. If ln of a quantity is a constant, then that quantity itself has to be a constant. Only if a quantity is a constant will ln of that quantity be a constant. So what is our conclusion here? tv to the power of gamma minus 1 is a constant. Now, this is one equation for adiabatic process. When you deal with an adiabatic process, by the way, what is the characteristic of an adiabatic process? The amount of heat added or removed from the system will be 0. The system is isolated. No heat get added or taken away from the system. For such a process, tv to the power of gamma minus 1 is a constant. What does it mean? It means if T1 is the temperature in state 1 and V1 is the volume, the state changes to T2, V2. It means T1, V